Science comes in many forms. Science is defined as the study of structures and behaviors of the physical and natural world through experiments and observations. This encompasses many fields, from repairing old artwork to nuclear physics. There are lots of different ways to measure and observe our world. We look at two examples, a study of jellyfish movement by Jack Costello and a study by Christy Rogers about gigantic dinosaurs. These will give us a view of the wide range of ways scientists view their work. There are certain things that we need to keep in mind while doing science. We need to think logically. We need to keep precise and accurate notes. And we need to be precise and accurate. And we need to keep an open mind about the plethora of scientific abilities and fields. Jack Costello studies jellyfish. He decided to film moon jellies in their natural habitat to get a better understanding of them. He noticed that moon jellies' bodies aren't well designed for underwater travel. Whenever they pushed their bodies forward, they wouldn't move. The large flat heads with weak propulsion made it so that they would only stay in the same spot, or they would be moved by the current. This seemed strange. Why would such a creature evolve this way? The answer is a real no-brainer. Ha! To continue their research, Costello flew an infant moon jelly into his lab and placed it in a tank. I guess you could call it a phytoplankton. Oh my gosh, what? He filled the tank with water and small bulbs. As the jellyfish moved its body, it created a current that sucked the bulbs up into it. This meant that the moon jelly's apparent weakness was actually a strength. They could use this to suck food up into their bodies instead of actively hunting. This is a great example of using live specimens, in-person observations, and using photographs and videos to study nature. Christy Curry Rogers studies dinosaurs. She wants to know why and how dinosaurs are so big. She saw small dinosaur eggs and massive dinosaurs and wondered, how can they go from so little to so massive in such a short amount of time, reaching maturity in only 10 years? And we think we grow fast. Ha! She began by hiking in the mountains for fossilized dinosaur bones. When she had gathered enough material, she took them back to the lab and took a wafer-thin, cross-section. Sorry, had to look that up in a thesaurus. So she cut a wafer-thin cross-section of bone. She took this bone and observed it under a microscope. What she found revealed the truth about dinosaur growth. There were large and chaotic patterns scattered across the cross-section. These patterns come from blood vessels from when the dinosaur was alive. Having large chaotic blood vessels is a sign of rapid growth. This meant the dinosaurs grew quickly, within 10 years. Curry Rogers used physical, non-living evidence and a lab with a microscope to legitimize her theory. So, after looking at these two different examples, we can see that Curry Rogers and Costello had far different ways of finding evidence. One was able to use live, easily visible materials in their experiments, and the other had to use long-dead materials that had to be looked at under a powerful microscope. Both of these scientists used laboratories as rooms to experiment in, and both had to observe physical evidence, but Costello had the luxury of using living models. Costello had modern evidence of jellyfish movement because he was able to get his hands on a real jellyfish to observe its movements. Curry Rogers probably couldn't have gotten her hands on a dinosaur, so she had to generate ideas about something that no one will ever be able to see. They both had a different approach because of the different things they were studying. In the end, they both got results. All scientists need to follow a sort of code to stay well regarded. First of all, the results must be replicated in some way, with few exceptions. This means that other scientists need to be able to go and do the same thing they did and get the same result. Some fields, like archaeology, can't follow this rule because, well, you can't rebury a lost city and find it again. Well, it makes me sad. Scientists also need to be objective. This means they don't let their personal opinions or biases get in the way of science. And backing this is logical thinking. Most scientific practices rely on thinking in a logical way. 2 plus 2 is 4, minus 1 does 3, quick math, and so on. They also need to be precise and accurate. There's a difference. Whoa. Accuracy is how close to the same result you can come using well-trained people with good calibrated machines. Precision is how many times you can get the same answer with the same method. Through all of this, scientists need to keep an open mind, but they can't let it wander too far or it won't come back. We have to see how many different fields of science there are. Archaeology is as much a science as physics, and so is carpentry and welding. Instead of seeing what they want you to see, you must open your eyes to the possibilities. There are many forms of science. We have everything from astrophysics and botanists to actors and influencers. We can see how science is done using Jack Costello and Christy Curry Rogers as examples, dinosaurs and jellyfish. Though we may be blinded by science's brightness, we must keep to our basic values. We must keep an open mind about science.